Speech is more than just communication. It's how we express ourselves. It's how we connect. It's our identity. But just imagine that speech was taken from you. That is the reality for 100,000 laryngectomy patients. A laryngectomy is the surgical removal of the larynx, often caused by post-cancer complications. And literature shows that over 50% of these patients suffer from anxiety or depression. Now, we spoke to these patients through the Cancer Laryngectomy Trust, and they told us existing devices they use to communicate, they feel robotic, unnatural, inconvenient, and they're hard to maintain because they're invasive. They told us the ideal solution would be non-invasive, non-obtrusive, natural sounding, hands-free to operate. And then we realized none of the existing solutions include all 4 of these criteria points. So that's where we wanted to fit in. We then spoke to clinicians from the NHS who explained the clinical contraindications of working with patients who might have post-surgical or irradiated skin. But they also told us that patients will only use devices that feel natural to use. So we had a wearable in mind, and so we approached Meta and 11 Labs to get their input on our thoughts. And after all of this, this is what we came up with. We, Team Stealth, are proud to present to you our vision for VOX. It's a silent speech interface that uses conformable electrodes to take in facial SEMG data and transform that into human-sounding output. We envision a simple 4-step patient experience, which require a few technical aspects. Due to the time constraints of this project, we focus on a few of these, which Damir is going to tell you all about.
All right. So on the technical side of the project, we split it up into 3 main sections: the materials, the data processing, and finally the classification of those words. So let's start with step 1, the materials. We broke this down into a further 3 steps: the formulation of the electrodes, the cutting of the electrodes into our desired geometries, and finally, the wire bonding to our own electrodes. And here in this section, the materials, lies our competitive advantage, which separates us from the rest. We had the great opportunity to leverage the Green Group Lab's patented dry electrode technology. Emphasis on dry because there's no gels, no skin prep, more accessible. It was also more comfortable and actually provided better signal quality than the rest due to lower impedance from the material. So all of these just made it more ideal for long-term use. Now onto the data processing side. Well, after interviewing clinicians and the patients, we identified 6 key words which met the basics communication requirements. And then after consulting literature, we also identified 8 optimal electrode placements, but also avoided the neck area. Now, we went through some basic signal pre-processing, and that feeds us nicely into the machine learning side, where again, consulted literature, we opted to use a one-dimensional CNN to start with, but we're going to continue to validate and improve these models as we continue. So, as you can imagine, there was a lot to deal with in the short time frame, so it was vital for us from a project management side of things to parallelize the process. So, first dependency being ethics approval. We can't just go around slapping around lab-made electrodes, so we had to seek permission first. So we used commercially available electrodes, which looked a bit like this. And so after that, the second dependency being making those custom electrodes, which looked a bit like this. Now, we actually had time to iterate and reformulate our electrodes, a version 2.0, if you may, and they ended up looking pre-cut like this. All right. So essentially, this is how the project timelines were spread out. By that team, they looked a bit like that.
There were many risks associated with this project, and I'm going to walk you through the most severe and likely of these. When we were collecting data, there was a risk of inconsistent baseline noise, which could have jeopardized the vocabulary classification. So to mitigate this, we controlled the grounding, which reduced the likelihood of this risk. Taking forward this quantitative approach to risk management, we realized there was a risk of the CNN having low decoding accuracy, so we had a backup binary classifier. And the first electrodes we made, they could have failed, which would have held up the software pipeline development. So we took our first round of data with the silver chloride electrodes, as Damir said. To conclude, we'd like to thank Professors Riley Green and Dario Farina for their support. We hope that our project will act as a gateway for future research to benefit the laryngectomy patients that we have set out to serve. Thank you.
About, are you about? Alhamdulillah.
Oh my god, bro, you smashed it.
Yeah.
Honestly, I got nervous.
Did you hear my temp? Did you hear a voice?
No, I couldn't tell. But
So, take it.